How's it going, guys? Today we're going to be going over section 7.3, day 1, where we're going to be learning about differences of cubes, sums of cubes, and about factoring by grouping. All right, we're going to touch on that again. So for number 1 and number 2 in your notes, we're asked to factor each polynomial completely. So for number 1, all we can really do is factor out 2x. So that's where we'll start. That's where we'll start. When we factor it out, we're left with x squared minus 10 inside the parentheses. Okay? And from here, we can't really do anything. X squared minus 10 is about as factored down as we can get. So this is our factor for number 1. For number 2, first thing we're going to do is factor out 3x. If you ever have a GCF in a polynomial, that's the very first thing you always want to do. So we'll factor out 3x. Let's actually do this in a different color. When we factor out the 3x, we're left with 2x squared plus 5x plus 2. Okay? So that's our GCF. We factor it out. This is what we're left with. And now we're going to factor what's inside of the parentheses. I'm going to use the box method. So what goes in the top is our AC. So our 2 times our 2, which is 4. And we need factors of 4 that add up to give us our B value of 5. All right, so that will just be 4 and 1. So now we'll make our box. All right, the top left corner is our ax squared. Bottom right corner is our C value. And our diagonal will be our factors that we just solved for. So we'll take a GCF of one row. The GCF of the first row is 2x. And now we'll divide the first row by 2x. And when we do, you get x and 2. And for the for the bottom, for where the 1 is right now, that should be a 1, since when we divide x by x, we get 1, and you divide 2 by 2, you get 1. That's just what it should be. So our x plus 2 are over here, and our 2x plus 1 over here are our factors of what's in the parentheses. So we'll bring down our 3x. We'll rewrite our factors, x plus 2, 2x plus 1, and this will be our factored form of number 2. All right, did them a little quickly. This should be a review for you. So let's keep on going. Recognizing special factoring patterns, we need to remember the patterns we already know. Remember the perfect square trinomial. Perfect square trinomials. There's 2 of them, and the difference of 2 squares. A squared minus b squared. That should be a plus b times a minus b. But now there's 2 more factoring patterns that we need to know. There's the sum of 2 cubes and the difference of 2 cubes. Okay? The sum of 2 cubes will be when we have an a squared plus a b squared, hence the name sum of 2 cubes. And that will equal a plus b, the first parentheses, the signs match, multiplied by a squared minus ab plus b squared. Something to note is that this second parentheses over here in the factored form is non-reducible. It's irreducible. You cannot factor this anymore, and also it has to be a minus ab, not a minus 2ab like a perfect square trinomial. If it was minus 2ab, we would have to reduce it some more. So remember, the second parentheses has to be irreducible. Okay, so the difference of 2 cubes, just like the name says, we're subtracting 2 cubes. So we have a cubed minus b cubed. In this case, it'll be a minus b, the signs match, multiplied by a squared plus ab plus b squared. And once again, that second parentheses is irreducible. You should not be able to factor it. And it's plus ab, it is not plus 2ab. Okay, plus AB. So let's go on and do a few problems. For number 1, we have 27x cubed plus 64. How we could rewrite this actually, and we could rewrite it to be 3x all cubed plus 4 cubed. Right? It's the same exact thing. 3x times 3x times 3x gives us 27x cubed, and 4 times 4 times 4 gives us 64. So our pattern here will be the sum of 2 cubes, right? We have 2 cubes going on over here, and we're adding them up. So our pattern will be the sum of 2 cubes. Our a value will be 3x, and our b value will be 4, right? it should be a cubed plus b cubed. So our a is 3x and our b is 4. So if we're going to factor it out, we need to remember what our factoring, what our equation is. So for our sum of cubes, what we should get is a plus b, 3x plus 4, multiplied by our a squared. So 3x all squared gives us 9x squared, minus a times b, 3x times 4 is 12x, plus b squared of 16, right? Remember, it's a squared minus ab plus b squared. All of that multiplied with a plus b. So that's where we got our factored form, and this is what our final answer is. That is what our factored form of the polynomial of number 1 is. Okay? Number 2, I'm actually going to leave that one for you guys to try on your own. I think it's pretty straightforward. We've done a lot of things very similar to this. The only difference is now we're using cubes instead of just squares. So I'll leave this for you guys to do on your own. You can double check your work with the completed key we have online. And we're going to go on to number 3. For number 3, it's a little different, but still ultimately very similar. We have 40x to the 4th plus 5x. So anytime we're trying to factor something out, like I said from the beginning of the video, whenever we're trying to factor a polynomial, the very first thing we should look for is, do we have any GCF? If you have a GCF, you want to pull it out. It's going to make your life much easier with factoring. So here we see we have a GCF of 5x. So I'm going to pull out the 5x. And when I do, I'm left with 8x cubed plus 1. So I see what's inside the parentheses. That is a difference of, a sum of cubes. All right. So if we were to rewrite what's inside the parentheses, so we can see how it's a sum of cubes a little clearer, we can rewrite this as 2x all cubed plus 1 cubed. Right? And we can see we're adding 2 cubes. So if we're adding 2 cubes, that means our factoring pattern will also be a sum of cubes. Okay. And now we need to decide what our a and our b is. Okay. So our sum of cubes, remember, it's a cubed plus b cubed. We can see that our a is going to be 2x, and our b will be 1. Okay. So we have our a, we have our b. All that's left now is to put it into our factored form. All right. So our factored form will be a, which is 2x, plus b, which is 1, all multiplied by 2x squared, or a squared, minus a times b. 2x times 1 is just 2x, plus b squared, which is 1. And we just completely rewrite this, make it completely as factored as possible. 2x squared is just 4x squared minus 2x plus 1. And almost forgot to put the 5x back down. Don't forget, we factored this out. We have to put it back down. Almost forgot about it, and that would not have been correct. So we brought down what we factored out. We have our factored form of the ax cubed plus 1. That is our completely factored form of the polynomial for number 3, right? So just to recap really quickly, the first thing we should always look for is, do we have a GCF to factor out? If you do, factor it out, and then from there, see if you can factor it out any more from there. When we factor out the 5x, we saw we have 8x cubed plus 1, which is a sum of cubes. So we can use the sum of cubes formula that we just learned to factor that out even more. And when we do, we get the form, get the factored form 5x times 2x plus 1 times 4x squared minus 2x plus 1. Okay? So let's keep on going. All right, so now we're going to talk about factor by grouping. We touched on this in 6.5 a little bit, factoring by grouping. So this is just another technique to factor polynomials, okay? So what we're going to do here is we're going to pair up terms of the polynomial, and we're going to see what we can factor out from each pair. So let's go over number 1. Number 1, if we were to rewrite it, we get x cubed plus x squared plus x plus 1, we can group up the first two terms and the last two terms, and we're going to see if we have any GCFs to pull out from each pair. So for the first one, we can pull out an x squared, and when we do, we're left with x plus 1. And for the second pair, we don't really have anything to pull out, so I'm just going to put a 1 since that is the GCF of x and 1, and rewrite the x plus 1. So that's what I have now, and what I see is that we have a common pair of parentheses. So what I'm going to do is I'm going to factor that out. So I factor out the x plus 1, and when I do, I'll be left with the coefficients that were in front of those parentheses. So, or in other words, I'm left with x squared plus 1. Okay, and now we need to double check, can I reduce this anymore? We can't. The x squared plus 1 is as factored as it can get. So that is our factored form of number 1 and how we do it with factor by grouping. All right, so now let's go over number 2. We're going to do the same thing. I'm going to rewrite it, and then we're going to factor it using grouping. Okay? So factor by grouping, like I said before, we're just going to pair up terms of the polynomial. So we'll put the first two together and the last two together, and we're going to factor out a GCF. For the first pair, we see our GCF here is just going to be p squared. So I'll factor out a p squared, and when I do, I'm left with 2p plus 5. And for 6p plus 15, my GCF there is going to be 3. So I'm going to factor out a 3. And when I do, I'm left with 2p plus 5 as well. So I see I have a common term or a common parentheses over here. So I'm going to factor that out. And when I do, I'll be left with the coefficients of those parentheses, which will be p squared plus 3. I've got a parentheses over there. So that's what we get. Again, we're going to double check. Can we reduce this any more than we already did? I really can't. 2p plus 5 is as factored as it can get. P squared plus 3 is also as factored out as it can get. So this is our simplified fraction, or sorry, our simplified polynomial of number 2, or factored out polynomial of number 2. That's the correct way to say it. Okay? So for number 3 and number 4, I'm actually going to leave that for you guys to do on your own. You just do it the same way that I did in the previous problems. We're going to post the completed key and the completed notes and the completed homework all on Canvas alongside this video. So you can always go back and double check. It's a very good idea to always be trying to work these problems on your own so you have a little more practice with them. Okay, I don't want to sit here and just do them all for you. So for number 3 and number 4, I want you guys to kind of try doing it on your own and double check your work with the key online. Okay.